So in this particular segment, we are going to deal with the concept of similarity. Okay. And this year our work is restricted to the similarity of triangles, though the concept of similarity can extend to shapes other than triangles as well. So let's start off with a very simple idea. Suppose I was photographing, say, a particular duster. Okay, assume that this is the duster which is placed on the board. And let's assume that the length of this duster is, say, 9 centimeters. Okay, and the breadth of this duster is, say, 3 centimeters. Okay, these are just some hypothetical values. Now, suppose I decide to make a magnified view of this particular object. By the way, the 3D shape is a cuboid, but on 2D, it's going to look like a rectangle, right? So assume that I'm going to zoom in this particular duster. So when I say zoom in, what I'm going to do is I'm going to take a photograph such that each side of the duster becomes twice. Okay. So this is, say, zoom of 2x. Okay. Zoom of 2x. That means all the sides are going to be doubled. That is, the length now becomes 18 centimeters. And the breadth now becomes 6 centimeters. However, the angles, so the angle of the original duster is 90 degree. The new angle, the angle in the magnified image is also maintained at 90 degree. So you will notice that each dimension of this duster is getting doubled. The length is doubled, the breadth is also doubled. And the angles, however, are maintained constant. So if I were to write this down, I notice that all sides of the duster are increasing or are multiplied by the same value. That is, if the length is doubling, then the breadth is also doubled. Whereas all the angles are maintained constant, right? Are maintained the same. Then these two figures are called as similar figures. So these are two similar rectangles, whereas on the other hand, if I decided to take a smaller photograph, that is a diminished image. So when I say that I'm going to take a diminished image, let's assume that each side of this duster was multiplied by 1/3. That is, the length became 3 centimeters. So if the length became 3 centimeters, it's not difficult to notice that the breadth would have become 1 centimeter, because 9 divided by 3 is 3. So the length is getting divided by 3. Therefore, the breadth should also get divided by 3. So the length is 3 centimeter and the breadth is 1 centimeter. So therefore, this means that these two rectangles are also similar to each other. So in one case, the original rectangle is shown in red. In one case, the rectangle is getting magnified, that's the yellow rectangle. And in the other case, the rectangle is getting diminished, that is the blue rectangle. These three rectangles are similar to each other because their sides are zooming in by the same proportion or by the same ratio, and their angles are being held constant. So there is no change in the angles of these figures, if you notice. So that's one important point. The angles have to be maintained the same, whereas the sides of the figure can change, but if they change, they have to change in the same ratio. Okay. So if you have, instead of a rectangle, if now say I talk about a square, Okay, or let's talk about a triangle. So if I take a triangle, then if this is the original triangle, if ABC is the original triangle, then if I want to construct a triangle which is similar to this, let us name that triangle as PQ and R. Okay, so let's name the triangle as PQ and R. This is P, this is Q, and this is R. Now if this side is 2 centimeters, AC is say 3 centimeters, and BC is 4 centimeters, then if I want to construct a triangle which is similar to it, let us magnify the triangle. Magnify the triangle means let's make it bigger. Assume that I'm multiplying each side. So AB is multiplied by 1.5 times, let's assume. So if I make this triangle 1.5 times larger, that is each side is multiplied by 1.5, then this side becomes 3 centimeters. This side becomes 3 into 1.5, that is 4.5 centimeters. And this 4 centimeter base will be multiplied by 1.5 to make it 6 centimeters. Then these two triangles are similar to each other. However, please notice that angle B will be equal to angle Q. The angles will not change. Angle A will be equal to angle P, and angle C will be equal to angle R. These two triangles are therefore similar to each other. So in a nutshell, I can say two triangles are similar. Two triangles are similar if their sides grow or reduce by the same ratio, and their angles are equal to each other. That is, 3 angles of one triangle should be equal to the 3 angles of the other triangle. If this is satisfied, then the two triangles are said to be similar. So now let's understand more about similarity. Let us understand the symbol of similarity and also the different conditions of similarity. Let us also compare similarity with congruency. So the symbol, let's see what is the symbol for similarity. The symbol for similarity is as shown on the board. Okay, it is like a sine curve. Whereas for congruence, the symbol was, if you remember, the symbol was a sine curve with an equal to sign under it, right? So this is the sign of similarity versus this is the sign for congruence. If I say that triangle ABC is similar to triangle PQR, let us see what all it means. First of all, it means that the corresponding angles are equal. So angle A is the first letter. Angle A is going to be equal to angle P. Then angle B, the second vertex, is going to be equal to angle Q. And the third vertex, which is angle C, is going to be equal to angle R, right? So the corresponding angles, so I can write this as corresponding angles of similar triangles are congruent, right? So the short form of this would be CASTC, right? So CASTC means corresponding angles of similar triangles are congruent. Also, if triangle ABC is similar to triangle PQR, it means the ratio of the side AB. So we know that when two triangles are similar, their corresponding sides are in the same ratio. So it would mean AB upon PQ, okay, AB upon PQ should be equal to BC upon QR, which should be equal to AC upon PR. So please note how I took the order of the vertices. I took the first two vertices of the first triangle and the first two vertices of the second triangle. I took the ratio. So AB upon PQ was equal to BC upon QR. So BC was the side joining the second two vertices and QR was the corresponding side. So BC upon QR, and then I had AC, the side formed by the first and last vertices. That was in ratio with P and R, that is PR. This is called corresponding sides of similar triangles are in proportion. Okay, so the short form of this is CSST, right? Corresponding sides of similar triangles. Okay, and we don't write the proportion part here because the proportion is already described in the equation. Let's compare this with congruency. If I had triangle ABC, congruent to triangle PQR, then what would be the different conclusions that I would reach? Angle A equals angle P, angle B equals angle Q, because those are the corresponding vertices, and angle C equals angle R. So these would be corresponding angles, okay, corresponding angles of congruent triangles, are congruent. Or the other short form for this was CACTC, or we could also write it as CPCTC. Corresponding parts of congruent triangles are congruent, right? So these are the two short forms for this particular phenomena. And if the triangles were congruent, their corresponding parts would be equal, right? The corresponding sides would be equal, which would mean AB would be equal to PQ, and BC would be equal to QR. So BC would be equal to QR, and also I would have AC equal to PR, right? AC equal to PR. This would be because of corresponding sides of congruent triangles are congruent, or it was also known as CPCTC. So the main difference between similarity and congruence is, in congruence and similarity, the corresponding angles are equal. There is no difference between them. But as far as sides are concerned, in case of congruency, the corresponding sides are equal, whereas in case of similarity, the corresponding sides are in proportion. Okay, this is the difference between similarity and congruence. Now, congruence is definitely an outcome of similarity. So what I can say is, I can make a statement as follows. Let's consider that the ratio of the sides is 1. Okay, so let's have a special case. So let's make a special case. Let's make a special case where AB upon PQ is equal to BC upon QR is equal to AC upon PR. Let's assume that this is equal to 1. So if this is equal to 1, it would mean AB is equal to PQ, then BC is equal to QR, and AC is equal to PR. That would mean that the two triangles are actually congruent to each other, right? And it is illustrated by the rectangle that I'm highlighting right now. Yeah. So similarity, therefore, is just an outcome of congruence is just an outcome of similarity. So we can say that all congruent triangles are similar, but all similar triangles are not necessarily congruent. Okay, so now let us see some more examples on similarity. Rather, now we should take some tests of similarity. But I'm going to leave you with this particular slide for a minute or two so that you can just grasp what is written on the board, and if there are any questions, you can definitely note them down for me. Okay, let's continue with understanding similarity in more great depth. Let us take a few examples based on similarity. So suppose I am given that triangle ABC is similar to triangle PQR, and I have been told that AB is 3.2 centimeters, PQ is 4 centimeters, and BC is 5 centimeters, and let's assume that PR is say 10 centimeters. I wish to find the dimensions QR, and so find QR and AC. Okay, so let's see how to go about this particular problem. I know that triangle ABC is similar to triangle PQR. This is known. So this is given to me, right? And because the two triangles are similar, I can say that AB upon PQ, the ratio of the corresponding sides AB upon PQ is equal to BC upon QR, which is equal to AC upon PR, right? The ratio of the three corresponding sides is equal, which means the length of AB, I can now substitute what I know. So 3.2 divided by PQ is 4 is equal to the length BC is 5 divided by QR is something that I want to find, and AC is what I have to find. So AC divided by PR is 10. So now let's see how to go about this question. First, what I will do is I will take these two equalities. And by the way, the reason for this is corresponding sides of similar triangles. So now I will take 3.2 divided by 4 is equal to 5 divided by QR. And on cross multiplication, I get 3.2 times QR is 4 times 5, which means 3.2 times QR is equal to 4 5s are 20. And therefore, QR is equal to 20 divided by 3.2. Now I can multiply both the numerator and denominator by 10. So it becomes 200 by 32. Divide both by 8. So this becomes 25 by 4. And therefore, the length of QR is 6.25 centimeters. Right. So this is how I can use this the principle of this ratio to find the unknown side. Now, similarly, let us try to find the side AC. What I can do is I can again use the first ratio and the third ratio. They are equal to each other. So I will say 3.2 divided by 4 is equal to AC divided by 10. 10 goes for a multiplication. So 3.2 into 10 by 4 is equal to AC. 3.2 into 10 is 32. 32 by 4 is 8. And therefore the length AC is 8 centimeters, right? So this is how I can find the length AC. And generally, whenever you have two triangles similar to each other, the first thing that should come to your mind is their corresponding angles are equal and their sides are in proportion. So these are two important things that should strike you as soon as you see the concept of similarity. So now let's go ahead and let's see some tests for similarity. So let us list down some tests for congruency first. So what were the tests for congruency? The tests for congruency were as follows. There were 5 tests of congruency that we have learned. The first one was SSS. Then we had the SAS test for congruency. Then we had the ASA test for congruency. Then we had AAS test for congruency. And lastly, we had RHS test, right? Now, let's list down what are the tests for similarity. So, something that we should understand is S stands for side and A stands for angle, okay? So, now let's write the test for similarity. There are 3 tests for similarity, so a much reduced version than congruency. The tests for similarity are, first test is SSS, the second test is SAS, the second test is SAS, and the third test is AA, okay, or AAA test for similarity. Okay, so let us understand what these tests for similarity really mean. Let us now understand the SSS test for similarity, okay. So let's write the SSS test. What does the SSS test really mean? SSS test. SSS test stands for side, side, side test. What it means is if the three sides of one triangle, and three sides of another triangle, are in the same ratio, then the triangles are similar. So let me explain this. If AB divided by PQ is equal to BC divided by QR is equal to AC divided by PR. So basically what we have here is the three sides of triangle ABC, that is AB, BC and AC, and the three sides of the other triangle PQ, QR and PR. If their ratios are equal, then I can say that triangle ABC is similar to triangle PQR by the SSS test. So basically I should have three sides of one triangle. Let's take some quick examples to understand how to apply the SSS test. Let's assume we have these triangles, okay, and let's take some hypothetical measurements, say 2, 3 and 4, and these measurements are 4, 8 and 6. Okay, now let's be very careful here. So we have triangle ABC and PQR. You will notice that this length 2 is getting doubled to a length of 4. Then the length 3 is getting doubled to length of 6, right? Similarly, the length 4 is getting doubled to a length of 8, and therefore because the three sides are in the same ratio, so what I can say is in this triangle AB divided by PR is equal to, so that's 2 by 4, which is basically half. Then I also have BC divided by PQ. So BC is 4 and PQ is 8. So this is 4 upon 8, which is also half, right? And if I take AC upon QR, so let's take AC upon QR. AC is 3 and QR is 6. So 3 upon 6 is also half. So these three sides are in the same ratio, right? So therefore from this I have all the three sides, all the three ratios are equal, which means AB upon PR is equal to BC upon PQ, which is equal to AC upon QR, right? All the three ratios are equal to half, and therefore I can say that triangle ABC is similar to triangle. Now let's see the corresponding points. So A is where 2 and 3 meet, and R is where 4 and 6 meet. So A is corresponding to the point R. So it is R. Then B is where 2 and 4 intersect, and P is where 4 and 8 intersect. So B corresponds to P. B is the second letter here, so P has to be the second letter, and C corresponds to Q. Therefore, these two triangles are similar to each other by the Sss test. So what you have to do is you have to be very careful in finding out the right proportions and the right corresponding sides. What I mean by that is, it is quite natural for you to compare 2 and 4. Okay, 2 and 4 you see them easily, but then you might be lost with 3 and 8, correct? Because they are not in the ratio 1:2. But you have to be attentive enough to look for 3 and 6 and then look for 4 and 8, right? So you have to have all these combinations done in your head to find the right combinations of sides so that the ratios are equal. So if the three sides of one triangle are in the same ratio as compared to the three sides of the other triangle, then the two triangles are similar by the Sss test. So let me pause for a minute so that you can grasp what was done here, and then we will continue with the Sas test. Okay, let's now continue with the Sas test. So the name suggests that two sides should be in proportion. Mind you, the Sas test in congruency was two sides should be equal. So let's quickly note that down over here so that it's easier to understand the similarity part. The congruency Sas test meant that two sides should be equal. Two sides should be equal, and the included angle should also be equal. Then the triangles were congruent by the Sas test, and that's why the angle is included between the two S letters. Whereas in similarity, what it says is, so let's write down the test for similarity here. So let's understand the Sas test for similarity. So the Sas test says, it stands for side, angle, side. Okay. What it says is, if two sides of a triangle are in the same ratio with two sides of another triangle, and the included angle is equal, then the triangles are similar by the Sas test. So what it means is, if I have AB upon PQ equal to BC upon QR, and if angle B is equal to angle Q, the included angle is equal, then the two triangles are similar. Let me draw a figure and illustrate this. So let's consider these two triangles that I have. This is, say, ABC and PQR. Let's assume AB is 10 centimeters and BC is 8 centimeters. Whereas this is PQ is 2.5 centimeters and QR is 2 centimeters. And let us assume this is 40 degrees and this angle is also 40 degrees. Then these two triangles are similar. Let me explain why. Let's take the ratio AB upon PQ. So what is the ratio AB upon PQ? 10 divided by 2.5. 10 divided by 2.5 is 4. Similarly, BC divided by QR is 8 divided by 2, which is also 4, right? So in this case, I have AB upon PQ is equal to BC upon QR, which is equal to 4. Both the ratios are equal to 4, and I have angle B equal to angle Q that is given to me in the question. Both are equal to 40 degrees. Then these two triangles are similar by the side angle side test. So side angle side test says, let's quickly summarize it. Two sides in proportion, and included angle should be equal. Okay, then the two triangles are similar to each other. Let me again pause for a minute or two, and then we will go to the AA test. Okay, let us now go to the AA test. The AA test is the simplest of all tests. The angle test says that, or sometimes it is also called the AAA test. Now I will tell you why both the tests are the same. See, if two angles of two triangles are equal, then the third angle automatically has to be equal, right? If there are two triangles and say that two angles are 60 and 40, then the third angle automatically has to be 80 degrees in both the triangles, because both the triangles will satisfy the angle sum property of the triangle. The sum should be 180. That's why instead of comparing all three angles, it is just sufficient to compare two angles of a triangle. So if I have so AA test is basically the angle test. Okay. And it is not necessary to compare all the three angles. Though if you can compare all three angles, that is also fine. That is the AAA test. But if, again, as I said, if two angles are equal, then the third angle is automatically going to be equal. So the angle test says that if two angles of triangle, if two angles of one triangle is equal to two angles of the other triangle, then the two triangles are similar. Then they are similar. Okay. So what it means is, if I have angle A equal to angle X and angle Y equal to angle B is equal to angle Y, right? And the triangles are ABC and XYZ. So triangle ABC will be similar to triangle. So A corresponds to X, so X here. B corresponds to Y, so Y would be here. And then there would be Z, right? So angle test is actually the most frequently used test for similarity. So we will take up some questions now where you will notice the AA test being used, and it is a very common sight to use the AA test because of some peculiar problems. Okay, so let's now start with some problems on similarity. Okay, so let's consider this question which is shown on the board. We have triangle ABC and we have DE drawn parallel to BC. We have to prove that triangle ADE is similar to triangle ABC, and the measurements are also given. We have to find DE. So first of all, let us see how to prove ADE is similar to ABC. I know that DE is parallel to BC, so that's given. So let's write the proof here. The similarity proofs are written quite similar to the congruency proofs. So given that DE is parallel to BC, therefore I can say that because of corresponding angles, so angle D should be equal to angle B. So angle D should be equal to angle B because of corresponding angles, right? And similarly, angle E should also be equal to angle C, again because of corresponding angles. So angle E equal to angle C, again because of corresponding angles. Now you will notice that in triangle ADE, so imagine triangle ADE differently and ABC as a separate triangle. You will notice that triangle ADE is similar to triangle A, D corresponds to B, so D corresponds to B, and E corresponds to C. This is because of the AA test. Do you notice that? Two triangles of the triangle ADE, so let's shade those angles. Angle D is equal to angle B and angle E is equal to angle C. Oops. Angle E equals angle C. So two angles of one triangle are equal to two angles of the other triangle, and that is why by the AA test these two triangles are similar to each other. So the similarity part is proved. So now if these two triangles are similar, I can say that AD divided by AB should be equal to DE divided by BC, that should be equal to AE divided by AC, and this is because of corresponding sides of similar triangles, right? So this is the reason. Now what all do we know? Let us mark all the parts that we know. We know AD is 8 centimeters. So this is 8 centimeters. BD is 7 centimeters. This is also known. BC is 12 centimeters. So this is known. So let us write all that we know here. AD is 8. So 8 divided by AB. Now AD is 8 and DB is 7. So AB is going to be 15. So 8 by 15 is equal to, DE is something that I'm trying to find out, or I have to find out. So DE divided by BC is 12, right? And therefore 8 into 12 divided by 15 is equal to DE. Now I can simplify this by 3. So 3 4s are 12, 3 5s are 15. Therefore DE is equal to 32 by 5, which is 6.4 centimeters. Therefore the length DE is 6.4 centimeters. So you will notice over here that there is a particular pattern. If I have a triangle within another triangle and the two lines are parallel to each other, then we have the AA test of similarity being satisfied here. And if you were to ask me about the ratios, I would like to highlight something over here. So let me draw this figure again over here. So let us just see how the proportionality is built. Let me shade it. So this length AD divided by the total length, that is AB, is equal to AE, that is this length divided again by the total length, right? And that is equal to DE, that is this length divided by the third side of the bigger triangle, which is BC, right? So this is how the ratios of the triangles are built, and here AA test definitely helps you. So let me pause for a minute and then I will go to the next question. Okay, so let's go to the next question now. So in this question, again we have to prove that ADE is similar to ABC. So again I have a right angle, not a right angle triangle. I have a triangle within another triangle. So what I'm going to do is, again I'm going to say consider triangle ADE, okay, and triangle ABC for similarity. So this is how I write a similarity proof, which is very similar to a congruence proof. So consider these two triangles for similarity. Angle D is equal to angle B. The reason being these are corresponding angles, right? So these are corresponding angles. So these two angles are equal to each other. Then instead of showing angle E equal to angle C, I'm going to play a different trick now. See, angle A is common in both the triangles, right? So angle A is equal to angle A. That is because it is the common angle. And corresponding angles, because DE is parallel to BC, that is why they are equal, right? So angle A equals angle A, which is common, and that is why triangle ADE is similar to triangle ABC. This is by the AA test of similarity. AA test of similarity. Now I need to find the length of DE. BC is 4.5 centimeters. So because these two triangles are similar, I will say AD divided by AB is equal to DE divided by BC, which is equal to AE divided by AC. And this is corresponding sides of similar triangles, right? And what is the length of AD? By the way, that is not given to me now, right? So now let me see what is given. AD is half of BD. That means if AD is X, then BD is going to be 2X, right? So I can mention that. I know that AD is half of BD. So let AD be equal to X. If AD is equal to X, it means BD is 2 times of X. And therefore, that makes AB equal to 3X. So now let us substitute what we know. If I know that AD is X, so I'm making the substitution here. So X divided by AB. So AD is X. How much is AB? If you look at the figure, AB is 3X, which equals DE is supposed to be found out. So DE divided by BC is 4.5. Therefore, 1 by 3 is equal to DE divided by 4.5, which means DE is equal to 1/3 of 4.5, which is 1.5 centimeters. So this is how I can use the concept of similarity to find the unknown side. I am going to pause for a minute and then we will take up the next questions. However, this is all that we have for the session today. Okay, so we end today's session over here. Let's continue with more similarity problems from the next session.